Welcome to another lecture for the UBC course ISCI 344 Game Theory. Today we're going to be going through the solution to the IESDS worksheet. My name is Rick and my co-teacher is Christoph. So first, let me give you some background information, what we plan to do and how we want to tackle this worksheet. We're going to talk first about preference circles, then we'll use them to find the Nash equilibrium, I should say Nash equilibria. We'll also discuss how we can use them to simplify the process of the IESDS. And since it's a part of the worksheet, we will also look for the POs, the Pareto optima, in the reduced matrices. Okay, let's start by looking at the preference circle. The idea is that you simply circle preferences that are preferred for each payoff given one of the co-players' options. I should say each of the co-players' options. And we'll use a solid circle to indicate strict preference, meaning that that option or outcome is better than any of the alternatives. And we'll use a dotted circle to indicate weak preference, meaning that there are some other alternatives that are just as good, but amongst all of them, it's still one of the best. And I'll just remind you that we're talking here about unilateral choices. So we're assuming that our co-player has a fixed choice or makes a fixed choice, and we explore each of them in turn. And given that, what is best for us? So we move unilaterally. Now, if both players, or I should say if an outcome is preferred by both players, meaning that both of the payoffs in an outcome are circled, then we've got a Nash equilibrium. So this is an alternative to using preference arrows to find the Nash equilibria, and it can be better in cases where there are a lot of arrows that you would need to draw, because this focuses you immediately on the best outcome for each player. So how does that translate into a Nash equilibria? Well, let me use red to indicate the row player. The row player could have a solid circle for any particular outcome, or possibly a dotted circle. And let me use blue for the column player. If both outcomes are both payoffs are circled, the column player could have a solid circle or a dotted circle. So these are the four possible combinations of circle. If both payoffs in an outcome have solid circles, then both players strictly prefer this outcome, which means it's a strict Nash equilibrium. If one or both of the payoffs is dotted, that means that's a weak preference, and we have a weak Nash equilibrium. Okay, let's apply this to our worksheet. Okay, let's have a look at the worksheet. So the task, there are 4 things that need to be done. First, apply IESDS to simplify the matrix as much as possible. Find all the Nash equilibria. Look at the full matrix. Are there any outcomes that would be mutually preferred over the Nash equilibria? Pareto improvements. We're going to go about this a little bit different. We're going to first find all the Nash equilibria by drawing preference circles. Then we'll apply IESDS. And then in the reduced matrix, we're going to look at the Pareto optima, just because there's a lot of them and that would be tedious to do for the full matrix in this video. Okay, let's take a look at our first matrix. So in matrix A, to solve to find the preference circle, here's the procedure. Let's first consider the row player, which means we hold the column player fixed with a fixed strategy. So we might say column player chooses C1. Then what is the preference for the row player? And we'll see here that the row player either gets 1 or 1, and so they really don't have a preference. Either of these is the best option. So I will indicate that with a dotted circle around the payoff. Now we look at column 2, and again we look at what's best for the row player. And in this case, -5 kind of sucks. -2 is better than that, so -2 is preferred. This time it's strictly preferred. And if we look at column 3, again we'll see that the row player is indifferent. Each of these is as good as the other, so those are weak preferences. Okay, now we go through the same thing for the column player. What would the column player prefer? And to do that, again, we have to fix the other player. So we say first, what if the row player chooses R1? Then which of the payoffs for the column player is best? And you can see here that it's +1. So I will indicate that with a solid circle. And we go through the same thing for the second row. If the row player chooses R2, what would the column player prefer from 2, -1, and 0? And obviously it's 2, so that gets a solid circle. Okay, now to identify the Nash equilibria, it's any outcome that has both payoffs circled. So I see 2 of them here. This R1C3 and this R2C1. They each have a dotted circle within them, which indicates a weak preference. So they're each weak Nash equilibria. And I will indicate that with W and E. Okay, now what we can also do is use these preference circles to indicate or suggest which rows or columns we can eliminate through IESDS. And to do that, notice that no row or column that contains a circle, whether it's solid or dotted, can be eliminated for that player's preference. So let me walk you through this a little bit. So if we look at the row player and their first strategy, R1, we'll see that there's a circle for actually each of the outcomes. So IESDS cannot eliminate that because this is the preferred outcome for the row player. So let's move on to row 2, R2, and we'll see that there's, again, the row player prefers this outcome, although weakly, which means we can never eliminate this strategy, at least not until we do some other reduction maybe. So let's turn things around and look at the column. So column 1, now we're looking at the column player and we see that there's a preference. So this will not be eliminated. Column 2, there's no preference. So this is a candidate. So just by looking down here, because we don't see any circles in blue in the column player's preferences, we have a candidate for elimination. It doesn't guarantee it, but it means it's one we should look at. And just moving on before we look at that one more carefully, if we look at column 3, again, we do have a circle, which means it won't be eliminated. So the only one we potentially could eliminate is C2. And now we need to look at that one more carefully. And if you do look at it, you'll see that C1 is better than C2 for both R1 and R2. And likewise, C3 is better than C2 for both R1 and R2. So that means C2 can be eliminated. So I will just scratch it out. Now, potentially, that's eliminated one of our circles as well. So it could be that we now can eliminate something for the row player that we couldn't before. But in this case, that's just not true. We still, if we look at the row players' options, in the first case, R1 still has a preference circle here and another one here, and likewise, there's one here and here. So there's still preference circles for R1 and R2, so we can't do any further elimination that way, and we can't do any further elimination to the columns either. So we've reduced this to a 2x2 matrix. Now looking at these, I'll just quickly look for the Pareto optima, and remember, these are the points where there's no possibility to find a Pareto improvement, where one or both players would do better and no player would do worse. So if I look at each of these and compare them, each of the remaining boxes and compare them to the other, I see that this could be improved on by going to here. 1, 2, if I compare it to the others, there's no way to improve upon that. So that must be a Pareto optimum. Continuing on, if we look over here, we can get an improvement by moving down here. And likewise, if we start here, we can get an improvement by moving here. So this is the only Pareto optimum in this reduced matrix. And as we saw, it's also a weak Nash equilibrium. So that suggests, I'll just point this out, that one of these weak Nash equilibria is maybe preferred over the other one, because both players would rather be at this weak Nash equilibrium than this weak Nash equilibrium. So hopefully they can resolve the game to arrive at that outcome. Okay, that's the first one. Let me move on to the second matrix. Okay, let's have a look at this second matrix. Again, we want to draw the preference circles, and I'm going to go through it a little bit faster this time so you get a feel for it. First, looking at if the column player chooses N, what is the preference for the row player? 80 is the best, so that's strictly preferred. Moving on to column C, 63 is best. Moving on to column J, 66 is best. Okay, now we can look at the column player, and now we look across and we say if the row player chooses N, which payoff would the column player prefer? And in the first case, 25 is worse than 42, 32 is worse than 42, so 42 is best. In the second row, 54 is best. In the third row, 31 is best. Okay, now notice that we have one outcome which is strictly preferred by both players. So that is a strict Nash equilibrium. And again, we can look at the process of IESDS through the lens of these preference circles, and we want to look for rows and columns that don't contain any circles. So if we look at the rows, oh, there's a red circle here, red circle here, and the columns, oh, I see, there's no red circle there, but there is in this one, blue circle here and here. So this column potentially is a candidate for removal with IESDS. And what we have to do now is look for the strategy that might beat it, if there is a single one. So 25 versus 42, okay, that beats it. But 26 versus 12, no, 12 doesn't beat it. So that's not the one. C does not dominate N. But we could look at 25 versus 32, yes. 26 versus 54, yes. 27 versus 29, yes. Okay, so that means N is dominated by J, which means we can eliminate N for the column player. Now in doing that, we eliminated one of our preference circles too. So now if we look across here, we'll see that there's no preference circle in the middle row. So that is potentially a candidate for elimination. And we have to look for a strategy that beats C, row players C. And I see J. For both of these, J beats C. So we can eliminate C for the row player. So that gets us down to a 2x2. And again, we eliminated a circle. And if we look at this column here, now there are no circles left for the column player. So that's a candidate for removal. And we would look and see that indeed it can be eliminated. So now we've got a 2x1 matrix and we've eliminated another red circle. So we might look at the row player and say, in this row, are there any red circles left? And no, there aren't. So that means that this is a candidate for removal. And indeed, 63 is better than 57. So we can eliminate that strategy. Correction, eliminate this strategy. So really, this IESDS has gotten us down to a single outcome. Everything else has been eliminated. And the only thing that remains happens to be the strict Nash equilibrium. And as you'll recall, IESDS will never eliminate Nash equilibrium. Let me also just circle or highlight the remaining outcomes in the first matrix. And I'm going to highlight them with background color. And I'll do that for the second matrix as well. Okay, let's move on to the third matrix. Okay, let's move through it more quickly. First, we'll look for preference circles for the row player. Weakly preferred, strictly preferred, strictly preferred. And for the column player, strictly preferred, strictly preferred, strictly preferred. So that means we found a weak Nash equilibrium here, a weak one here, and that's all. Do we have any candidates for IESDS? We do. If we look at each row in turn, we'll see that there is no red circle around any in the second row. So that's a candidate for removal. Can we find a strategy that always beats B? Yes. I see that C always beats B. So B can be eliminated. That eliminates one of the preference circles, and of the remaining in that column, there are no preference circles. So there's a candidate for elimination. Here also is a candidate for elimination. So we should compare those and see whether either of them can be eliminated. If I compare to A, I don't need to compare the middle row anymore. But if I compare little b to little a, then I can see that B is always dominated. Little b is always dominated by little a. So little b can be eliminated. Let's also look at little c at the same time. And again, it can be eliminated. Okay, so that brings us down to a 2x1 matrix. And the question is, can anything else be eliminated? And no, we don't have any candidates for elimination because we have circles in both of these boxes. So the row player, there's a dotted circle here and a dotted circle here. So neither can be eliminated. So that means that we're down to a 2x1 matrix. I had planned to also look at all the Pareto optima, at least for the reduced matrices. We can do that. I forgot to do it for matrix B, so let's look at it now. We're down to a 1x1 matrix, which means this is the only and preferred outcome for all players, so it's automatically Pareto optimum, only in the case of the reduced matrix, not looking at all the rest. So I will mark that with a P. That's a little hard to see. I'm going to switch to black. And looking at the matrix C, do we have any Pareto optima? Just in the reduced matrix, if we look at 1, 1, we can see that there's a Pareto improvement if we move to 1, 5, and there can't be any Pareto improvements from there. So this must be a Pareto optimum. Okay. Let's move on to matrix 4. This is a big one, so I'm going to move through it pretty quickly. Looking at the row player for column little a, strictly preferred, strictly preferred, strictly preferred. And looking at the columns, strictly preferred. Okay, now we look for boxes that contain 2 circles. I see 1 here. Okay, and looking for rows or columns that don't contain any circles of that player's color. This column does not contain any circles for the column player, so it's a candidate for elimination. And if I look it over carefully, I can see that little a is dominated by little c. Okay, what else? I can see there are no red circles in row D, so let's look for that. Is that a candidate? Well, it is a candidate. Can it be eliminated? I see that D is always dominated by, big D is dominated by big B. Because we eliminated this circle, I'm going to look for column B now and see if and notice that it's a candidate now, and see if it can be eliminated, if it's dominated by any other strategy. It looks to me like B is dominated by little e, and in doing that, we eliminated another circle here. So let's look at row C and see if it can be dominated. I see that big C is dominated by big B now, and that gives us a clue where to look next because we eliminated another circle. So let's look at little e. It looks to me like although e is a candidate, it turns out it can't be eliminated at this point because although 45 is better than 19, 0 is not better than 3. So e is still preferred some of the time, or at least it's not dominated. So let's look elsewhere. Where else can we look? We could look at big A because I see that there's no red circles left. So is there a strategy that dominates big A? I see that big B dominates big A. We eliminated a circle, so let's, in column D, so let's look at D and see if it can be dominated. And I see it is dominated by C. So we're down to a 2x2 matrix at this point. Let's keep going. Looking at the columns again, I see that column little e is dominated by column little c. And finally, looking at column C, rows B versus E, I see that the row player would strictly prefer B over E. So row E is dominated by row B. So we've reduced this entire 5 by 5 matrix down to a single outcome. And of the remaining outcomes, it must be a Pareto optimum. There are also Pareto optima that you can find in the rest of the matrix, but this is the only one in this 1 by 1 reduced matrix. Okay, let's continue on to matrix E. First, we'll use our preference circles. So for the row player, that's strictly preferred, weakly preferred, strictly, weakly, strictly. And for the column player, these are all identical, so they're weakly preferred. In the next row, we have just zeros and minus ones, so the zeros are all weakly preferred. Oh, this is no good. I've got the colors backwards. I'm going to just correct these before I move on to the last row. Okay, and let's finish up with the last row. And we can see that there are two boxes that have both payoffs circled, one here and one here. There are dotted circles in those boxes, so those are weak Nash equilibria. Now, are there any rows or columns that don't have any circles? Every row has at least one circle. Column, column, column. Here's a column that doesn't have any of the payoffs for the column player circle. So is G dominated by any other strategy? Almost dominated by D. It's weakly dominated by D, but not strictly. I think I see one. Yeah, looks like G is dominated by B. That doesn't get us very far, because although we've eliminated two circles, there are plenty more to go around. So I think that's all we can do for elimination, which means we've taken a 3 by 8 matrix and made it into a 3 by 7, which isn't very helpful. Maybe a little bit. And I could look for Pareto optima in this case. I will leave that for you to think about. Are there any Pareto optima that you can find? And let's move on to matrix F. Okay, our last matrix. Let's go through the exercise of circling our preferred outcomes for each player. I'm seeing a pattern here. And for the column player, okay. And are there any boxes that have both payoffs circled? I don't see any, which means we can't find a Nash equilibrium. Huh, that's something weird to think about. Okay, but in the meantime, let's look at our dominance and see if we can eliminate any strategies. I see column 0 doesn't have any strategies circled, and if we compare it to column 5, it's clearly dominated by column 5. So it can be eliminated. So maybe we should check row 1 now. And yes, row 1 can be is dominated by row 0. And that suggests to us we better check column 2, because we eliminated a circle. And yes, column 2 is dominated by column 1 now. Again, we've eliminated a circle. Let's check row 3. Row 3 is dominated by row 2. We eliminated a circle in column 4, so let's check column 4. Column 4 can now be, is now dominated by column 3. We eliminated a circle in row 0, so let's check it. But no, there's still another circle in row 0. So row 0 is not a candidate for elimination. The remaining rows 0, 2, and 4 each have a circle in them. The remaining columns 1, 3, and 5 each have a circle in them. So none of them are candidates for elimination, and I think we're done. So let me highlight what we have remaining. So we've reduced this 5 by 6 matrix to a 3 by 3 matrix. And let's see if there are any Pareto optima in our reduced matrix. 414. Any Pareto improvements can be made? I don't think so. You can't beat to 14. So this must be a Pareto optima. How about 12-4? 12-4, nope, can't beat 12-4. 10-4? Yeah, 12-4 beats it. How about 412? Well, 414 beats it. 212, 414 beats it. 10-2, 12-4 beats it. 410, 414 beats it. 210, 414 beats it. 010, 414 beats it. So I'm seeing two Pareto optima in this payoff matrix, in the reduced payoff matrix. Okay, I hope this has been helpful to you to just go through the exercise and follow along. If you found it confusing, I recommend you just try it for yourself, and at each stage you try it and then you listen to what I said and what I was trying to explain, and try to make sense of it. But it's really important for you to try things first, to figure out what it is exactly that you don't understand about something. Okay, I'll stop the video now, and I'll see you in class.